All right, this is part 2 of our 1.5 factoring notes. So now we're going to talk about factoring trinomials by grouping. Last time we did talk about factoring trinomials that had a leading coefficient of 1 right here. But these are not going to have a leading coefficient of 1, so you can't do what we did yesterday. We also talked about factoring by grouping yesterday, and so the reason we did that is because the way that you factor trinomials properly, when there's a leading coefficient other than 1, is by grouping. So first, I want to take a look at FOILing these two binomials, and then we're going to use the steps to factor it and maybe just make a connection there of what's happening. Okay, so when we FOIL, when we multiply these two polynomials, I get 6x squared plus 3x minus 8x minus 4. Okay, so now I have 4 terms. Notice the middle two are like terms, so we can combine those. And we're done. So now I'm going to take that exact same polynomial, 6x squared minus 5x minus 4, and we're going to factor that using grouping. So it says for a trinomial ax squared plus bx plus c, and this is where a is not 1, but you actually can use this even if a is 1. It's just not as easy. Like you would want to use the other method because it's a little quicker. So step 1, find 2 factors of a times c. So yesterday it was factors of just c, but this time we have a times c that add to b. So factors of AC, a times c on this problem is negative 24. So that's 6 times negative 4. So if you're wondering where that comes from later on, it's our a times c. And our factors, I'm not going to do 1 and 24. Let's do 2 and 12, 3 and 8, 4 and 6. And now we want the ones that add to negative 5. So they need to multiply to negative 24. So one's negative, one's positive, and they're adding to negative 5. So I need to make the 8 negative. We're going to use 3 and 8. 3 and negative 8. Okay, so we did step 1. We found the 2 factors that multiply to a times c and add to b. Now we want to split the middle term using the factors found in step 1. So we are actually going to split this one up into 3x minus 8x. Do y'all agree that 3x minus 8x would be negative 5x? So those two would be equal. It's equivalent to say that. So now I have 6x squared plus that minus 4. So look what we just did. We went from this to this. I'm just splitting those two middle terms up. But if you look back over here, 3x minus 8x. All we did was uncombine the like terms. So when we FOILed, we had 3x minus 8x right here, and then we combined it to get negative 5x. What we did here is we split that middle term up into those two like terms, so it's like before they were combined. Interesting. Okay, now keeping right along, step 3, now there are 4 terms. Use the grouping method to factor. So the method we did yesterday, where we grouped the first 2, grouped the last 2, factor out the GCF in both, that's now what you can use now that there are 4 terms. So group the first 2, group the last 2, make sure that negative goes in the second group. but put a plus sign in between. Okay, now we factor out the GCF of each group, so that's going to be my 3x. 3x goes on the outside, leaving me with 2x plus 1. On the second one, -4. If you have a leading negative right there, like on the -8, you want to include that as part of your GCF always. And that leaves me with 2x plus 1. Okay, great. These two match, right? Our two leftovers, the 2x plus 1 and 2x plus 1. So we can factor those out, divide by 2x plus 1, put it on the outside, and leave the 3x minus 4 as your other factor. That makes up your other factor. All right, and that is how you factor a trinomial by grouping. Okay, so notice that we did go back to that original problem that we multiplied at the beginning, right there. My two terms are backwards, but you know, that's the same. You can multiply things in either order and you would get the same thing. So we're back to where we started. Perfect. All right, let's try some more examples of that. Got a few examples of this, maybe just because this is maybe what people struggle with the most. So we've got a few examples. Number 9. So step 1, find two factors that multiply to give you AC. So factors of AC. So that's -60, multiplying the 5 times the 12. 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. Okay, found it. My 6 and 10. We're looking for two that would multiply to -60, so one of them needs to be negative. I know the 6 needs to be negative so that they would add to +4. They need to add to +4. Okay, now we split this guy up into -6z plus 10z okay, wrote that kind of small. It's okay. We're going to group the first two terms, the last two terms. Factor out the GCF for both. So in the first one, 5 and 6 don't have anything in common. So I'm looking at the z's. I can only take out one z. Leaves me with 5z minus 6. Factor out a 2 here. Leaves me with 5z minus 6. Good. So notice they match. That's exactly what we wanted. We put our 5, we factor out the 5z minus 6. So just as a note here, if these two don't match, either you did something wrong or you need to rearrange the terms. So rearrange the two middle terms. That shouldn't happen here, but you probably messed up if these two don't match. All right. Not too bad. Number 10. Okay, and remember the first step is to factor out a GCF if you have one, but we don't have one here. So now we're looking for two terms that multiply to give us on this one 12 times 3, -36. And add to give us -5. So 3 and 12, obviously. 4 and 9. Okay, 4 and 9 works. 1 needs to be negative, so they multiply to give us a negative, and that is the 9, so that they add to give us the -5 in the middle. Okay, so we're going to split that up. I'm going to do -9t plus 4 t. The order does not matter on these. I put the -9 first so that when I split the groups up, there won't be a minus sign in the middle. But it really doesn't matter. All right, grouping the first two, group the last two. Factor out the GCF for both. The first one, 3t, so 3t goes on the outside. On the inside, I have 4t minus 3. Okay, looking at the second one, 3 and 4 don't have any common factors, and t is only in the first term, so there's no GCF there. You could think of it as just being 1. So there's like a 1 on the outside here. Okay, so we've got 4t minus 3 for both. Probably doing something right. 4t minus 3. And what would be left, putting that 1 there, is 3t plus 1. So you do need to include that 1 as part of your second term. It's not just 3t plus 0 or just 3t. It is 3t plus 1. Number 11. I feel like these three terms have a GCF because they're really big numbers, and I would never make up a problem that has such big numbers for you to factor. So looking for a GCF first, my factors of 15 are only 3 and 5, and these are not divisible by 5, but they are divisible by 3. So we're going to take out a 3. That'll make our problem a lot easier once we take the 3 out. Smaller numbers to work with. Always good thing. Okay, so now using our method up above, step 1, we're multiplying those two. That gives me 40. So two numbers that multiply to positive 40 and add to 14. Right off the bat, I'm thinking 4 and 10, right? So you could have got all of these other factors. Oops, not 1. But the only one that adds to 14 is 4 and 10. And you want it to add to positive 14, so both numbers need to be positive. Splitting this up into 4x plus 10x. Rewriting the rest of that, 8x squared plus, okay. So all we did was basically uncombine like terms from this middle guy. Okay, the 3 is still on the outside, so don't forget about that. Okay, step 2. Or are we on 3 now? We want to use grouping to factor this. So group the first two, the last two. GCF for both, that's going to be 4x. GCF for the second one is 5. Okay, so I've got a 3 on the outside. You can put either parentheses or bracket there, but you do need something. And then my 4x goes here. I've got 2x plus 1 plus 5 times 2x plus 1. Perfect. Factoring out, I actually won't need this bracket anymore. Factoring out my 2x plus 1 since they match. Oops. And my leftover is 4x plus 5. Great. Number 12. I'm not seeing any GCFs for 5, 7, and 6. X, Y, no GCF. So let's move right along. This is the first one where you have two variables, but it is going to work exactly the same. Okay, two numbers that multiply to give us, negative 30. 2 and 15, 3 and 10, 5 and 6. Okay, so they need to add to give us negative 7. It's going to be our 3 and 10. Since we need one of the numbers to be negative, that'll be the 10, so that they add to negative 7. Splitting this up into negative 10xy plus 3xy. Okay, grouping our first two and our last two. GCF for both. GCF here is 3y. Okay. GCF now is x minus 2y, so put that x minus 2y on the outside, leaving you with the 5x plus 3y. Okay, so see how we literally did the exact same process that we've been doing on the other ones, even though there was another variable involved. This is the last section that we'll do today. It's our perfect square trinomials. Perfect square trinomials. So if you see a trinomial of this form, basically where the first term is a perfect square and the last term is a perfect square, and then the middle terms, what will end up happening is there'll be 2 times a times b, 2 times that square root of the first term times the square root of the second term, the last term. Then it will always factor into, and you may actually remember this from our 1.4 part 2 notes where we multiplied these types of polynomials, but this will factor into a plus b squared. I think in those notes I used an x and a y, but it was exactly the same thing. We learned that if you had a plus b squared or x plus y squared, then it would follow a pattern when you multiplied it and it would give you this. So now that we're factoring, we can use the same pattern to factor it. It's going to give you a plus b squared when you factor it. Okay, and then the second one, same thing, but it'll come out to a minus b squared. And if you didn't notice that it was, that this pattern was happening, it would be okay. You would end up getting these factors at the end if you did everything correctly. So that's fine. But it is nice and easy. If you do notice the pattern, it will make your life easier as far as factoring these types of polynomials. So number 13. On number 13, notice the first term is a perfect square. It's x squared. I'm just going to rewrite this. The last term is a perfect square. That's 10 squared. And the middle term is 2 times x times 10. Right? This pattern 2ab, 2ab. That's how that works. And so we know that it's going to factor into just a plus b squared. So a is going to be the square root of the first term, which is x. B is going to be the square root of the last term, which is 10. And then it's squared. That's it. Okay, so helpful to notice the patterns. Okay, number 14. This one might be like a dead giveaway that you need to use the pattern because again, you've got some really large numbers there and there's no GCF. So I wouldn't really expect you to factor something multiplying 49 times 4 and then getting the factors of that would be very tedious. So kind of a dead giveaway that we need to maybe use the pattern. Okay, so this is, let's make sure we can see our patterns up there. Okay, so the first term is 7x squared. The last term is 2y squared. So make sure you're taking the square root of the number and the variable, the square root there. And the middle term should be 2 times 7x times 2y, 2 times 7x times 2y, which it is. You don't have to rewrite this, but I'm just showing you that it does follow the pattern. Okay, so now that we see that it does follow the pattern, we can rewrite this into a plus b squared, and it's going to be plus because notice that plus sign. The only difference in these two is the plus right here in front of the 2ab and the minus in front of the 2ab. So basically if there's a plus, you need a plus right here. If there's a minus, then you'll have a minus in the middle. All right. So this one's going to be 7x plus 2y squared. 15. So square root. This is going to be 3x all squared. This is going to be 6y squared. And the middle term should be 2 times 3x times 6y. Which means it's going to factor into 3x plus 6y all squared. Ooh, actually not. All right, this one actually didn't work. If you notice that middle term right there, the 2 times 3 times 6, that does not come out to 18, so you actually can't use the pattern. This one comes out to 36xy, not 18. I honestly can't remember if I did that on purpose to show you that it doesn't always work, or if I meant to put a 36 there so it does work. But either way, we won't be using the pattern on this one. But you could still factor that one using, well, first take out the GCF. First take out the GCF and then factor it like we did using grouping. Okay, so can't use the pattern on that one. 16, let's see, is there a GCF? We've got 9, 3, no, I don't see any patterns, any GCFs, so let's move on. Taking the square root of the first and the last term, that gives me 9ab. The last one is 5, so I'm going to check and make sure that this middle term is 2 times 9ab times 5. And it is. Yep. Okay, so now we can factor this, taking the square root of our first and last term to get a and b from our pattern. Notice there's a minus sign on this one, so we need a minus in the middle this time. So square root of this first one just cancels out that exponent. That's 9ab. And the last one, you got the 5. Square root of 5 squared is 5. All right, that concludes our notes for today. We will finish these in part 3.